Hey everyone, and welcome to our lesson on adding, subtracting, and multiplying complex numbers. Before we start our operations with these numbers, let's talk about what a complex number is. A complex number is going to have two parts, one real part and one imaginary part. The real part is just the plain number, and the imaginary part is the other number with the I attached. Remember that i's, the imaginary numbers, come from negative numbers under a square root sign. So that's where that comes from. Since those parts cannot be added together, we'll always express them separately. So to add complex numbers, we simply need to look at the parts that can go together, sort of like terms. When we see two complex numbers written beside each other that need to be added, we're going to scan across for the real numbers and then the imaginary numbers. You can see down here that we've added the real parts. 2 plus 4 gives us 6. And then the imaginary parts, 9i minus 2i, or we can think of it as plus negative 2i, gives us 7i. And we have to keep these parts separate. 6 plus 7i is our answer. Subtraction is going to work much in the same way. We're just going to look across our complex numbers, however many we have, and add up all of our real parts separately from our imaginary parts. So let's take a look at this example. We have this real number and this real number, 3, and a positive 10, but these are being subtracted. So on these, you want to kind of go through and see which group is being subtracted, because that negative sign is going to need to be distributed to that whole group. So I'm going to have to think of this as a 3 plus a negative 10. So you can see that we've put those together down here and arrived at negative 7. And then I have my imaginary parts here. That negative being distributed to the 4i gives us a negative 4i. So I've got 5i added to negative 4i, which just gives us our I. So written out for our final answer, we have negative 7 plus I. Alright, moving to multiplication. Since we will have two terms in each expression, one real part and one imaginary part, we're going to have to use our FOIL method to multiply these out. Every part needs to be multiplied by every other part in the second group. So FOIL is an acronym for first, outer, inner, last. So if we take these first two terms, 3 and 4, that's going to give us 3 times 4 is 12. And then the outer terms that I've drawn here, 3 and negative 6i, that's going to give us negative 18i. We're just multiplying these parts together. And then I need my inner terms, 2i times 4 gives us 8i. And then finally our last two terms, 2i times negative 6i gives me negative 12i squared. Think about this as maybe two x's coming together. What you're familiar with, you would end up with x squared. So the same thing works here with our i's. We'll end up with I squared. And something special about I squared is that it always equals negative 1. So anytime you arrive at an I squared in your solution, you're going to replace that with a negative 1 and continue to simplify. So let's take a look at that. I'm going to have 12, and then eventually these I parts can come together. And then over here at the end, I'm going to replace this I squared with negative 1 because that's what it's equal to. And we'll talk about that a little more in a minute. Alright, now I have 12 minus 18i plus 8i plus 12. You can see that these two negative numbers are going to come together to become a positive. So I can add my real parts, 12, and another positive 12 from this product that we will have. So that's 24. And then my imaginary parts, negative 18i and positive 8i gives me negative 10i. So here's our final answer with the real part and imaginary part, 24 minus 10i. Alright, here's another example of multiplying complex number. This one I wanted you to see, we actually just have a coefficient, just one coefficient number in front of a group, but we're going to treat it the same way and then leave our parts separate for our final answer. So distributing this coefficient in, we will have 4 times 3i, that's here, and then 4 times 9, so that's here, and 12i plus 36. And if you've noticed, I've written this one with the imaginary part first. It really doesn't matter as long as you keep them separated, but generally you will see the real part first. So you may see this answer written like this, 36 plus 12i. All right, one thing that we do need to talk about when talking about complex numbers is that imaginary part. You're going to come across higher powers of I in these problems, and the I cycle is really neat because it only cycles through 4 values and then it's going to start over. Remember that I comes from the square root of a negative number. I is equal to the square root of -1. That is its value. So when we look at higher powers of I, for every 2 of those, negative square root of 1 times another square root of -1, we are going to have -1. So remember, for every I squared, that is going to equal -1, and we looked at that in our example. And thinking about that, here for my I to the third, I will have 3 i's. 2 of those, remember, gives me a -1. So this is equal to -1i, and you can just write it as -i. All right, I to the fourth now is 4 of these i's multiplied together. And remember, for every 2, that's a -1. So let's think about what this would become. -1 times another -1 gives me +1. This is the I cycle. It's square root of -1, and then -1, and then -i, and 1, and then it starts over. So if you encounter an I to the 5th, 6th, and continue on, it's just going to start over with that same cycle. So you may come across those when you're dealing with complex numbers. But this concludes our lesson on adding, subtracting, and multiplying complex numbers.